Good day, engineers. As we all know, engineers consider bearing capacity when designing a structure to ensure its safety. Bearing capacity is the maximum load that the ground can support without failing, which assures structural safety and prevents excessive settlement. The program calculates both the ultimate and allowable bearing capacity. The SoilSafe Allowable Bearing Capacity Calculator was created by Group 9 of Batangas State University's Civil Engineering 1103 students. Throughout the video, members will demonstrate the main interface, explain each function, and show how the program works from input to output.
On this project, we have 5 main goals. First, to ensure structural safety by preventing collapse or settlement. Second, to improve cost efficiency by reducing material waste and costly repairs. Third, evaluate site suitability through soil support checks. Fourth, provide fast user input and reliable results. And last, ensure user satisfaction through accurate structural assessments.
The SoilSafe Allowable Bearing Capacity Calculator is highly relevant in the field of civil engineers and civil engineering students because it serves as an effective tool in preventing structural failure. So this project significantly enhances infrastructure safety. It assists engineers in ensuring that foundations are strong and reliable, especially in situations involving natural disasters like earthquakes. By providing accurate and reliable output, the calculator promotes safer and more resilient structural designs.
Our coding interface begins with a selection of choices, mainly to start the interaction by pressing X. Pressing Y will show you the needed information for the calculations, and by pressing Z to end the interface. After selecting Start, it will ask the user about the values needed for the calculations in the ultimate bearing capacity. The user will experience immediate and accurate answers for the bearing capacity of a soil can support depending on the structure. This can ease the execution of decision in actual scenarios. The ultimate bearing capacity calculator determines the highest load that the soil can support without falling, with the aid of the Zagi's geotechnical formula, which takes into account the inputs that build the foundation, providing a theoretical maximum load capacity. Converting the ultimate bearing capacity by prioritizing safetiness to get the allowable bearing capacity safe operating value. This aids in providing useful numbers appropriate for an actual construction, which helps engineers in creating foundations that are stable under practical circumstances.
So to demonstrate the defined functions of our program, let's proceed to the first one, which is the positive float function. This defined function replaces the input function so that only positive float values are accepted when the user inputs a value. When a user inputs a letter, the program will display input numeric data only, and if the user inputs a value less than 0, the program will display input positive values only without breaking the loop, and will urge the user to try and try again. This defined function ensures that the data to be inputted are correct. The next defined function is the interface. It displays 3 options, which are the start, the info, and the exit, with the XYZ to interact. Pressing Z for exit simply exits the program. Pressing Y for info shows the information about the program. Pressing X for start starts the calculation. It urges the user to input what kind of footing, may it be strip, square, or circular, with the 0, 1, 2 to interact. Upon finishing one calculation, the user can type Y to repeat the calculation with the same footing the user initially chose. If the user typed N for no, the program will return the user back to the interface to choose between starting another calculation, reviewing the info, or exiting the program. This interface function is an infinite loop that will only break when choosing N to the question, back to the interface after previewing info, or when choosing Z to exit the program. The next user-defined function is the main function. It is the function for calculating the ultimate bearing capacity using Zagi's formula. There is a main function for each footing. It is a while loop. Upon inputting the values and calculating the ultimate bearing capacity, there is another sub-while loop function for calculating allowable bearing capacity that urges the user to input a factor of safety, and then the result will be the allowable bearing capacity to be displayed. The sub-function will break once the user pressed Y for yes, meaning the user is sure of his or her factor of safety. If not, the user can always try again. Under the sub-function, there is also a conditional statement. If the final value is greater than 25, it means that the settlement governs the design. If less than 25, in the other hand, it will display shear governs the design. The main while loop is also infinite, but will also break when the user pressed N for no, thus will not repeat the calculation again, bringing the user back to the interface. There is also an import of iter tools, threading, and time for the calculating loading animation. The last defined function is the back function. It is a basic while loop function whose only purpose is when the user pressed Y for info in the main interface, the user is given a choice to go back to the interface or not. Pressing Y brings the user back to the interface, while pressing N will exit the program. That is why there is an import sys to execute system exit.